from another author, so not from me. First, I want to let you guys know I'm going to give the credit to this is a Stalin Chorus. So he has written a very, very good slide. So additive manufacturing. So additive manufacturing, also called 3D printing. I know you have maybe you have heard of this additive manufacturing, right? Is that right, guys? Additive manufacturing. If we see the name additive and we something come up to our mind, and it is subtractive. And subtractive manufacturing is usually talking about the machining operations we have learned, the drilling, the turning, drilling, this also this is milling. All of these, they are subtractive manufacturing. Subtractive manufacturing means that you have a raw material, and you reduce some of this material, and from this is the main material, main workpiece, and then to get the final products. So additive manufacturing is another direction, right? So the additive, and they build things together instead of subtract some things from something else. So this is two directions. So additive manufacturing is bottom to the top, and this subtractive manufacturing is top to the bottom. So there are two directions. So here, these are basics of this 3D printing. This is 3D printing coil, this at MIT, this one called at MIT in 1995. This is a layer. So this is the vase. Okay? So this is a vase, and this is a shape, and they built MIT people, and they just printed, we call printed, layer by layer. So we get this vase. So additive versus subtractive. So this is here. So this is layer by layer. We put them together, and this is additive. So this subtractive is, and this is our raw material. I want to get this part, all other small parts off. So that is subtractive. So this is subtractive manufacturing. So limitations, the subtractive, this is subtractive. This is our milling machine. So this is what are the limitations for the subtractive manufacturing? So can you tell me what are the limitations for subtractive manufacturing?
You can't undo any errors.
Read, say again.
If you make a mistake, you can't undo it.
Yeah, that is true. Another thing is that it wastes a lot of material. Okay, with a lot of material, and you can think about other things. The junk, very the bulky workpiece, and you want to get this part off, that part off, this part off, that part off. So also subtractive manufacturing, and in some cases, and you cannot do it. And for example, this is a complex, is a cellular structure, and there is no way for you guys to build it using subtractive manufacturing, no matter how much energy you have and how much money you have. This is very complex. So what is the 3D printing? The possible issues for this 3D printing: overhangs and support structure, and you need to have these support structures, and print direction, and fill in and hollow objects, where you should fill in material and where you should leave the hollow materials, what kind of material you should use. Right? So layer resolution. So this is layer, and what's the resolution? So this how thick and the layer should be. The price. So at the very beginning, this is very expensive because this is new, but now the price is diving. Okay, so because a lot of the people have been involved in this is 3D printing and additive manufacturing. Safety and ease of operation. Is it safe and ease? and need for post-processing. So this is needed for post-processing. Why? Because when you do the additive manufacturing, so these additively manufactured parts sometimes cannot reach the requirement of the dimensional accuracy and also surface finish. If this is the case, and you need to do the post-processing and to make the surface smoother and to make the dimensional accuracy dimension more accurate. So part of my research is doing this post-processing of this is additively manufactured CFRP. CFRP is a carbon fiber reinforced polymers. So this is the this have several nozzles. This is the hosting. This is the matrix material that is a fiber material, and you just several nozzles work together and to print out something. So I'm doing the post-processing research for this additively manufacturing now. So here is the overview of 3D printing technology, and we have fused and deposition modeling. This is fused deposition and the stereo lithography, SLA, and DLP 3D printing, and photo polymer phase change inkjet use ink, just like we print something on the piece of paper. And so this is ink, right? So the ink print something there. So selective laser sintering. So this is these material powders, and you use the laser and to melt some parts together. You have this selective laser sintering. So plaster-based 3D printing, and powder bed and inkjet head and 3D printing, and thermal phase change inkjets, and laminated object manufacturing. So after we finish this part today, upcoming Monday, I'm going to show you on how to 3D print. This is infrastructure, the houses, the buildings. Right? So this a lot of fun there. So first, I talk about fused and deposition modeling. So here, so developed by Scott and Lisa Crump in the later 80s. This is a long time ago. FDM is trademarked by Unstructured system. So this one is very, very prestigious. This is 3D printer manufacturer. So AKA fused filament fabrication. So these are 3 Fs. So here, this is the nozzle. This is the fused deposition. You deposit all these nozzle, this is the material coming out from this nozzle, and you just deposit them together on the stack by stack, layer by layer, and to have this finally, after this gets solidifies, and you can have the 3D printed or additively manufactured part. So this is Scott and Lisa Crump in the later 80s. The fused deposit modeling, this is FDM. So this here is a filament spool. This is a filament spool. This is a filament. So here is this roller is going to feed this filament to this chamber. This chamber is going to melt it. So filament is made of thermoplastic material. Thermoplastic, if you have some heat, thermoplastic material will melt, and this molten this material will be coming out from the nozzle, and you can just put them on another stacks, another layer. So this is ABS there, and so this is PLA and many new materials. This is a dual extruder machines exist. So there are 2 temporary support structure can be made from water-soluble material, and these are 2 colors here. So here is a support material. These are drive wheels. This is a filament material cartridge. So he's coming here, and heater blocks, liquefier. This is a modeling material, and this is a support material. And so this is a filament also coming here this way, right? So this process, this time lapse here. So you can just look at this YouTube if you are interested. So this modeling, the commercial system, you can buy. This is commercially available in the market. The strata system dimension, this family, the Z resolution is this 0.18 millimeter. It's small. And build size, you can be built 8 by 8 and 12 inch. This is the parts, limited color and limited material types. So this is fused deposition modeling. So this is fused deposition modeling. So there are other, this is 3D printers manufacturers, MakerBot, Delta 3D printer, Ultimaker, Cube. This is from the 3D systems and many others there. So we have talked about fused deposition modeling. Then we talk about the stereo lithography. So for this one, SLA, and they use liquid and photoreactive resin. The photoreactive, you use the resin there, and you use the photo and to make it solidify. Okay, so laser beam traces one layer on the surface of the resin, one layer of the surface of resin. So that layer of the resin will be solidifying. So laser light Qs, we call Q. Q is solidify. And solidifies parts, it heats. The platform descends by one layer. So platform descends by one layer. So I mean laser does not change. The platform, laser does not move, but the platform moves. So the platform exists by one layer. So your laser position of layer does not change. The layer can move on to the next layer. The laser. So this is a support structure. So they can build this kind of structure. This is very, very awesome, right? Thin support lattice can be broken off. This is very thin and can be broken off.
Professor, can you go back to the first SLA slide? So does the resin, does it come from the floor and then the laser melts it? Is that what you're saying?
No. And when laser hits the resin cools, and then it solidifies.
Right. Where does the resin come from?
The resin came from, this is just one. This is a laser beam, this is a laser. So these are solidified, and laser, they use a liquid photo reactive resin. This is I don't know where is the resin is fed. So this here, the resin is here.
Okay.
Resin is here, so this platform can be moved. So this laser come here, okay? Laser come here, and so laser comes here. Laser hits this layer, so this layer will be solidified.
Okay, thank you, Professor.
For liquid, originally, so this is the resin is liquid. When this guy is hit by the laser, and this guy cools and solidifies. So this reservoir, so this one contains the photosensitive, the polymer resin. So this will show you, this is the liquid. So this developed by Charles Howe in the 80s. Still, it's a long time ago, but at that time it is not very, very well accepted. This is technology. Coiled the term and stereo lithography and founded the 3D system in 1986. So two main families here, and project and iPro. So build volume varies, can be very large. Resolution can be up to 0.05 millimeter. Materials, only one can be used. And photopolymers, clean, opaque, temperature resistant, and ceramic-like, and ABS-like. So these clones, and Formal Lab, they have their own a smaller building volume, similar resolution, much less expensive. So this is Eiffel Tower. So we talk about the second one, and then we talk about the third one. A digital light projector. This is 3D printing. So this is the laser source, and this is DLP, digital light projector. This is lens, and this is photopolymer. So this is a stage, and so here is a motor there. So DLP 3D also uses liquid ultraviolet curable and photopolymer resin, liquid and curable. DLP exposes and solidifies one layer at a time on the surface of the resin. So Z-axis moves by one layer. Okay, so whenever the ultraviolet hits the resin cures and solidifies. So this guy, you can see this one is similar to the SLA. Laser mirror is replaced by a projector for this DLP 3D. And simple design, only 1 degree of freedom, so only in this direction. And faster than SLA, and material, same as SLA, no additional support material. So perfectly from Envision Tech. So you can look at this one. This is from the German company. They have Z resolution 50 microns. This is less than the previous one. XY resolution 50 microns. Project resolution, and 2800 multiplied by 1200 pixels, and build volume. So this you can build, and so big. This is a part. So inches. DATO cell, right? You can just build this one, and then buy the materials. This Eiffel Tower.
Professor, you said it was faster than SLA, but how long is that? Like, what's the time looking like?
I have no idea, but that one, this is layer, 3D by layer by layer. I don't have clear idea how fast it is. Good question. Look at this one, guys. Can you imagine if we use subtractive manufacturing, and how you can build these kind of things? Also, how you can build this Eiffel Tower is very, very, it's kind of impossible. So the third one, then we talk about the next one, photopolymer, the phase change inkjet. So inkjet, the printer head jets liquid photopolymer and supporting material, just like the printer we used to print out the pictures. But for that kind of picture, there is no thickness, right? But you can just build this one as thickness. Ultraviolet light cures photopolymer and support material. Excess material is removed using a roller. The platform descends by one layer. So this is jet head, just as the cartridge we have. Okay, this axis, y-axis, this is ultraviolet light, this is z-axis, and this is build tray. This is a full cured material, support material. This is a full cure, this is model material. So printing process. Can you see this video? Can you see this video, Ray?
No, we can't. You may need to switch screens. You're only sharing the PDF.
Okay, let me share my screen. the printing. I just show something, okay? You can read this one.
We can see it.
I can just see one layer, another layer. See? And you can compare and this what is being printed and something you are printing. When you print some color and using our common, this is a printer, and there's no thickness, right? So, but here is a thickness. That's awesome.
So is it printing metal also?
This is not metal. It's printing. Okay, I'm going to stop this. Where is it? Where is it? Where is it? What? Just 1 second. Okay, I got it. Okay, do you like it?
Yeah, 3D printing is pretty cool.
So the next Monday, I'm going to show you cooler things. How to print a building. How does that sound?
That sounds pretty cool.
Sounds awesome.
So this is the inkjet feature similar to SLA. Also use the photopolymer. The only technology supporting multiple materials, and currently 2 or more support materials. Materials we have, and they use this kind of materials, photopolymers only, and can be mixed before curing using graded material. Graded material means different densities, and soft, rigid, opaque, transparent, and different colors. So this is a commercial system. You can buy this one. You can buy this, this thing, the inkjet. These are sample fabricated objects. So they're using this as inkjet. This is 3D printing. So rubber-like material. This rubber-like, just this boot. So here is another video. You can take a look. Okay, so then we talk about the next one, selective laser sintering. So direct metal laser sintering. So SLS. So what's this? The powders here. You can see SLS and the DMS use a bed of small particles, powders, and they can be made of plastic, metal, ceramic, or glass. So high power laser, you use a laser and traces 1 layer on the surface of the powder bed and fusing the particle. Because the high temperature, and so this particle, when the particles are heated by the high temperature from the laser beam, and it becomes softer. They become a kind of liquid, not completely liquid, and these particles, they can be confused, can be fused together, can be pulled together. So that's the reason it's called fuse, sintering. So platform descends by 1 layer and more material is added. Okay, so this is, you can see this one. This is scanner system object being fabricated and fabricated powder bed. You want to build this one. So you can just scanner system, you can just make sure, so this laser comes here. So these particles will be glued together, quotation mark, glued together. So here, so use a bed of small particles, and same thing, high power laser traces one layer on the surface of powder bed, melting and fusing the particles. The platform descends by one layer and more material is added. So SLS and DMLS features laser and so similar laser and scanner system similar to SLA, but the laser is more powerful, and bulk material can be preheated. Materials using one material at a time, and can be materials can be glass, polymer, metal, and even ceramic, and don't require support structure. So single and two component powders. You can see this one, single component metal powder. So here is a two component metal powder mix. So here's a two component metal coated powder. So different, they are different, the powders there. Raw powder particles. This is raw nickel alloy copper powder mixture. So this is raw iron copper the powder mixture, sintered powder, and come together. Okay, the glued together or melted together. Single component Fe powder of the sintering. So this is other powder of the sintering. So here is and you can take a look at this. We don't have. You can take a look at this one. I will go put this one online so you can take a look at this process. So the history, UT Austin, this by this Joe Beeman and Carl Deckard, also 1980s. So there are commercial systems there available. And these are sample fabricated parts. So this one can be the metallic material. So look at this one. Can you imagine for this one, how can we use the subtractive method to solve to get this product? It's impossible. This lattice, we call this lattice, a 3D printed lattice. So this is a huge one, right? So this is a 3D printed titanium central the wing spar. This is huge. Airbus wing the brackets.
Hey, Professor.
How
do they print titanium?
Titanium powders, and use the laser and to fuse them together.
Got it.
Based on the shape. Yeah, you need to buy the titanium powders first. And then we talk about another one, plaster-based 3D printing. So this is use a bed of small plastic particle instead of other particle. Use the metal or ceramic. Ink jet printer head prints with liquid adhesive. The adhesive is used to glue things together. One layer on the surface of the powder bed and fusing the particle. The platform descends and by one layer and more material is added. So this is a plaster, okay? Plaster is used here. So similar to SLS and DMLS, does not require support structure. The only technology supporting full color the printing. You can have different colors. Materials, plaster only. Color can be applied typically on a near surface. Brittle requires post-processing. So here is a YouTube video, and you can take a look at this plaster and based 3D printing process. Right? So I'm going to, as I said, I'm going to post this one online on Blackboard. So this one is developed at MIT And in 1995, you can see all these, most of these 3D printing technologies, they are developed in 1980s or 1990s. So now it become mature. Commercialized by Z Corporation in 1995. So commercial system, they are available, commercially available in the market. So this Z Corporation. And Z Corporation is now 3D systems. These have another name. So these are fabricated parts. So this is, it's very, very cool, right? Then we talk about the thermal, the phase change inkjet. So just like the 3D printing. Inkjet print head jets and heated liquid plaster and support material. And this support material uses wax. Material droplets solidifies as they cool down. Excess material is removed using a milling head to make a uniform thickness layer. So particles are vacuumed away and the platform descends by one layer. So extremely high resolution and slow printing time, right? Material and use plastics and waxes. Support material and wax is very easy to remove. Manufactured objects are used as casting pattern, but almost never as final functional parts because of the strengths. So here are the commercial systems that are available. So they are samples fabricated parts. So this statue is very, very nice. So these are other things. This is a tools here is also good. So then we talk about the last one, laminated object manufacturing, LOM. So LOM, the sheet is this sheet is adhered to a substrate with a heated roller. Okay, so laser traces desired dimension of the prototype and laser across hatches non-part area to facilitate the waste material removal. I'm sorry. So platform with completed layer moves down out of the way, and fresh sheet of material is rolled into position, and platform moves up into the position to receive next layer. So we have a foil supply here, the heated roller, and laser beam. 3 is laser beam, and scanning prism 4. So laser unit, 5 is laser unit, and 6 is layer, and 7 is moving platform. The 8 is the waste. The waste can come out here. So this is printing. The process. I would highly suggest that and you watch this video. Okay, this you can get a lot of good ideas here. So these features inexpensive, and prison resolution is low, and color can be added. Materials, and you can use paper. Okay, and they're very nice, right? The plastics, composites, metal, ceramic, and support material, and same material can be used as a support. So these are support material. So these are the commercially available systems. So the highly system. So printing process, you can just watch this video. I highly recommend you watch this video. So these are fabricated objects. Okay, guys, that's all for today. And this okay, upcoming Monday. Hayden, you have something to say?
No, I was just saying thanks, Professor.
Okay, you're welcome. So next Monday, I'm going to show you on how to 3D print the house, the infrastructures, print the walls. There's a lot of fun there. Okay, so this one, I'm going to test your understanding of and how many 3D printing technologies we have talked about and what they are. Okay, so This is conceptual knowledge. But I want you guys to know how many different types of additive manufacturing processes we have talked about, and what they are, and what kind of characteristics they have. And you should know if you see this kind of problem in the final exam, and you should be able to come to this PDF file and to get